All right, number 11 for Math 150, review for test number 3. Again, solving for the absolute value, we first isolate the absolute value. So this -2 is in the way. So I'm going to choose to add 2 to both sides. That will then give me the absolute value of h plus 6, which is less than or equals to 0. Normally, we would then break it into 2 equations. One we copy exactly, h plus 6 less than or equal to 0. And then the other one, we would copy the h plus 6. However, we would flip the sign and change the sign as if we're dividing both sides by a -1. But the h plus 6 stays the same. We change the inequality, and then we change the sign of that number. The thing is, there's no such thing as a -0. So we just have h plus 6 greater than or equal to 0, h plus 6 less than or equal to 0. When we subtract 6 from both sides, we'll have this situation. Subtract 6 from both sides. And there we go. The problem is this is a bit of a trick question. When you go back and look at it, well, let's finish it out. If we're to graph it, this is an and. When our absolute value is less than or equal to something, we're going to have our graph looking something like this. So in this case, h is less than or equal to -6. So less than or equal to -6 would go that way. I'll put this one in blue. I'll put this one in green. Greater than or equal to -6. And because this is and, we're looking for the situation where the red, where does the point land on the blue and the green? Only right here at. So the solution set is really just the number -6. So if I were to graph this compound inequality or this absolute value inequality, the solution will be a point just at 6. If I check the work, if my h does in fact equal a -6, then what is the absolute value of h plus 6 and then subtracting 2? So if I put a -6 in there, I would then have the absolute value of 0 minus 2, which is 0 minus 2, which is -2. Note that -2 is less than or equal to -2. That is true. So h equal to -6 is a solution to our original equation that they gave us. And there is only one number that once you take the absolute value of it, because the absolute value of anything will be positive. So then to subtract 2 and have it be less than or equal to a -2 means that this absolute value has to be 0, which means h has to be 6. This is a more complicated problem, but the algebraic step-by-step process of how you solve it is the same. Isolate the absolute value. After you isolate the absolute value, write your 2 equations and then see what will make them true. Number 12, evaluate the root. This is the cubed root of -1. So that answer is -1 because -1 cubed does equal -1, meaning this -1 cubed is the same thing as this -1 here. This one would be no solution. There's no real number because you cannot have a negative under a square root. You cannot have a negative under any even index. This would be 1. This would be 1. This is the same thing as -1 times the cubed root of 1, which is -1 times 1. So this answer is -1. This is -1 times the square root of 1, which is again -1 times 1, which is -1. Converting the expression to radical notation, there's a negative. You need to remember that this exponent here is only applied to the d. It is not applied to everything. So this is the same thing as 6 times, and if I deal with that negative first, then I would have 1 over d to the 3/5 power. 6 is the same thing as 6 over 1. So I'll have 6 over d to the 3/5 power. And then we need to convert this to a radical notation. The denominator is your index. So that would be the 5th root of d to the 3rd power. And this would be your final answer. Number 14, simplify the radical. Notice that this is a 3rd root. And I know that the 3rd root of anything to the 3rd power will be that number. 16, the 1 to the 3rd power would be 1, 2 to the 3rd power, 2 times 2 times 2, 3 to the 3rd power, 9 times 3 is 9, times 3 is 27, 4 to the 3rd power, 16 times 4 is 64. Again, you should know 5 to the 3rd power is 125. And so on and so forth. Well, I don't need to go anything beyond 16, so I can stop right there. Can I rewrite 16 as a factor of 8? I sure can. So 16 is the same thing as 8 times 2. Then looking at this y to the 8th, what I'm looking for is what is a number smaller than 8 and divisible by 3. So number smaller than 8 and divisible by 3 is 6. Y to the 6th times y to the 2nd is the same thing as y to the 8th. This is my scratch work over here. Y to the 8th is the same thing as y to the 6th times y to the 2nd. So I have the cubed root of 8 times the cubed root of 2 times the cubed root of y to the 6th times the cubed root of y squared. This becomes 2 times the cubed root of 2. This is y to the 6/3, which is y squared. So I'll have 2. And then this one next would be y squared. And then the cubed root of, and then I'll just put everything that's under the radical. I'll leave it under the radical. And this would be the final answer. If you want it all in one color, it's 2y squared, 2 times y squared, times the cubed root of 2 times y squared. And again, the cubed root of 8, that's the cubed root of 2 cubed. So that is just 2. This is where this 2 came from. 14, 15, simplifying the radical. Again, cubed roots. My cubed roots, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. 6 times 6 is 36. 36 times 6, 216. And I'm already above the 192, so that's as high as I need to go. So this is the same thing as, sorry about that. 16 times the cubed root of 192. Grab the calculator, 192. What can I divide 192 by? 192 divided by 64 is 3. So here's my scratch work. 192, I grabbed my calculator and found out that's the same thing as 64 divided by 3. 81 is the same thing as 27 times 3. So 192, I will rewrite it as 64 times 3. Minus 9 times the cubed root of 81. But I'll rewrite 81 as 27 times 3. Again, in math, you have creative license to rewrite anything so long as it has the same value. So now I'm looking at 16 times the cubed root of 64 times the cubed root of 3 minus 9 times the cubed root of 27 times the cubed root of 3. So that's 16, and the cubed root of 64 is 4. Still times the cubed root of 3 minus 9 times the cubed root of 27 is the same thing as 3. Times your cubed root of 3 at the end. 16 times 4 becomes 64 times the cubed root of 3. 9 times 3 is 27 times the cubed root of 3. So I'm looking at 64 cubed root of 3. Because my radicals are exactly the same, I can factor them out. 64 minus 27 times the cubed root of 3. And that would be your final answer in simplified radical form. This original mumbo jumbo, this expression in the top green box is the same as the expression in the bottom green box. Where I got these numbers was just by cubing the integers. Questions or comments, send me an email. 16. Solve the equation. Solve means tell me the values that make it true. This radical is in my way. So the first thing, and I would notice it's an equation. So as long as I do the same thing to both sides, that's a legal math move. So the left side becomes 3w minus 2. The right side is 7 times 7, which is 49. Now do whatever you want to both sides to isolate that w. I'm going to add 2, not 3. Opposite of multiplying is dividing. And then I would check and put that number back into the equation. Figure out if 3 times 17 minus 2, take the square root, is that really 7? Last one. Base of a triangle is 9 feet more than the height. The area is 68 feet squared. Find the base and the height. You can use X and Y. I'm going to let B be my base and H be my height. When I'm grading your tests, there are usually a student or two that switch which is the base and which is the height. The other equation that will be needed is area. Area is base times height. And then the base is 9 feet more than the height. Is, your to be verb is your equal sign. So the base is 9 feet more than means the plus comes in front of the 9. 9 feet more than the height. So here are my two equations. Oops, I'll let you see all the problem here. I have one equation that says the area is base times height. I have another equation that says the base is height plus 9. And they also tell me the third piece of info, the area is 68 feet squared. So given this information, put it all together and solve. 68 is the same thing as base times height, but I'm using base of h plus 9. So I have h squared plus 9h. Once I realize I have a quadratic, I would like to use the quadratic formula or factor. So solve for 0. So I'm going to subtract 68 from both sides. And I'm left with 0 is the same thing as h squared plus 9h minus 68. If I have that situation, then the quadratic formula tells me that my variable will be the same thing as the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. We're still learning quadratic. My a is the coefficient before the h squared. My b is the one before the h. And my c is the constant. And go from there to solve. All right, I have negative times negative is a positive. 9 squared is 81. 81 plus 272 is 353. And it says, all right, what's an exact answer? So the square root of 353 is about 18.9. Negative 9 plus or minus 18.8 actually over 2. So that gives me two situations. H is negative 9 plus 18.8 over 2. 18.8 minus 9 divided by 2 is 4.9. So H will be 4.9, or the other option is that H is negative 9 minus 18.8 over 2. which is a negative number, which will be not the answer, because what we're looking at is a length. Negative 27.8 divided by 2. A negative length is not what we want, so that is my height. And then I plug it back into the original equation that I wrote up here. The height is 4.9. And because I used h, I know that height is 4.9. And then this equation here says the base is the height plus 9. So that would be 13.9. Final answer. And there's your answer for number 17. Keep the questions coming and keep up the good work.